One of the hidden features in Solid Edge are a tool called sensors, and this can have major benefit in sheet metal. Now, you can find them hidden over here in the sidebar. We can pin it in. If you can't see it, you can click on the drop down and turn it on in here. So basically, you've got various ones in here. I'm going to look at the sheet metal sensors first. And the idea is that in sheet metal, because of the deformation when you're trying to punch a hole, probably not quite so critical with laser cutting, but if you're trying to punch holes near edges or bends, then you could get a bit of deformation. So you want to try and avoid having those available. So if you set up a set of sensors in a sheet metal template, the settings are generally related to material thickness. So you may have templates for different materials and different thicknesses already set up. So you could set your sensor up in there. So what you would want to do is make sure that you don't have cutouts or holes too close to an edge or a bend. So if we click on the sheet metal sensor, I'll show you how to set that up. So I'm going to do it for the whole part, and then we're going to look at the distance between interior and exterior edges. So basically it's going to be the distance from the edge of this hole to the edge here or the edge here, and likewise with a cutout, the distance between these two in here. It may also be a distance between a hole and a cutout on here. So the final stage is to define what you want to check. So the first one here is exterior edges to interior edges. And then when you go finish, we get our options, and it shows you what the current distance is and the threshold we want. So typically it's say 2 times the thickness of the edge is the minimum. So you'd want to go say at least 4 mil for this 2 mil thick option here. You'll see that it's going to ask you to inform me if the sensor is less than 4 mil, and it's got an option of whether you update it automatically or manually. So automatic is probably the best option in here. So immediately we've come up with a warning. So even if this is hidden away, you'll still see that warning sign, which indicates that we have a breach on that sensor. And then you can go in, as I hover over it, you'll see that the edge of that cutout is too close to the edge of the part, and we need to fix that up. So we can find that cutout is this one here. So if we double click on here, we'll see that we've got a 2.5 mil distance on there. So we can change that to 4.5, and the sensor becomes green, which means it's an acceptable distance between the two. Similarly, we could do another one, and we can do holes to cutouts. And in here, there is a hole to hole or cutout to cutout, cutout to hole. So we'll go with that one. And likewise, we'd have a threshold of 4 mil again on that, and kick that off. And as you can see, we've got a failure on here, and as you hover over it, you can see the hole is way too close to the edge of that cutout. So we can edit that. So the cutout, I think, is 11 mil and 3 mil hole. So we need to increase that. if I hover over the thing, I've got it set up so that we can just scroll out, and when you get to a distance that is clear, the sensor becomes green, and we have satisfying condition on that now. So as you can see, when you're designing, you don't necessarily look at some of these options, and it's always good to know that these features are going to be manufacturable without too many problems before you start punching or cutting metal. So there's also some other types of sensors in here. There's a custom sensor, which basically has three options set. So there's a basic cost, a mass, and a measure distance. So let's just have a quick look at this cost sensor. And basically what we're doing is we're looking at a cost. I'm going to give this a name. I should have named these two as well. So in this one, we can look at doing a horizontal range or a true or false, which is this format here. But I'll look at the horizontal range this time. So the cost sensor is based on the number of features. So there could be holes, louvers, dimples, and so on. So what we can do is, let's say the threshold is 50, minimum is 0, and we can go up to 150 on there, and we can OK that. I should have just changed that to greater than. So we're only interested in situations where the general cost of the item is more than a certain value. So it's just a sort of a rough gauge. It doesn't look at the size of holes, or it doesn't actually look at cutouts. So that's something that can be added. So this is the program that is used to develop these custom ones, and you can download it from the Siemens download site, and you can then customize it to what you want. So as you can see, each feature has been allocated a token value. So holes 1.25, louvers 1.5, cost per bead is 2.25, dimple 2.05, and cost per bend is 1.25. Now, as I said, what you might want to do is come in and edit this. If I was doing it, I would, and add in cutouts. And with ordered sheet metal parts, you can actually easily get the profile length of a cutout. So you could base your value based on per millimeter or per meter length of cutout. It depends on whether you are laser cutting or whether you are going to be punching. So punched holes, you could put something in the feature, name the feature punched or laser, and then you could use that to develop further. So looking back at the part, you can get an idea of how that's built up. So as I said, this cutout here, if you look at the value, it's 46.8 at the moment, so it's within range. So if I suppress this, it's not going to change that value, but if I suppress the bead, that value drops down by the cost of that bead operation. We could also look at, if we look at the variables, we could change our hole pattern. So if we up that from 8 to 10, you'll see that then the cost sensor has been exceeded, and you may want to look at whether you want to change those values to give you a better result for your manufacturer. It depends on obviously what features you've got and what are essential and what are non-essential. So that just gives you a feel for how that cost sensor works. For the final sensor I'm going to look at in the assembly environment. So we still have our sensors tab over here, and I'm going to use the minimum distance sensor, and I'm set my options to solids only, so I'll check between that one and this one here, so that gives me the minimum distance between the two. So when you go close, that opens up the sensor box, and you give it a name as we have done before. So all the settings are pretty similar. So we've got a current value of 70, and we can set our threshold. We don't want it coming down below 50 maybe, and we want to set the range between 0 and 100. So that sort of fits. Yeah, we've got a less than option in there, so that creates this option in here. So if we then go into our variable table, I've got a variable set up on here, and we're sort of messing around, and we're sort of changing our values. If we're sort of moving things around, say we'll bring that down to 75, and yeah, that's sort of fine. You're sort of messing around. Let's obviously change that again. So let's go 150, and obviously it's moving the tank across. And now in sort of doing a messing around, you'll see that we've got the marker on here and on the window, and obviously you can see that we've breached that sensor. So you can set these things up if you've got critical measurements that you want to keep track of while you're changing around with your design. You can set these up, and this will give you an indication when you are running into problems. So hopefully this gives you an insight into how sensors work. There's quite a big range. You can customize your own, and yeah, they're pretty useful, especially in the sheet metal environment.